Hey, welcome back. This is episode 21 of the Salesforce Architect Playbook. Today, Salesforce off-platform heavy compute architecture. Decoupling heavy business logic with AWS EventBridge, SQS and Lambda. Let's get into it. Here's what we're covering today. The governor limit ceiling, on-platform versus off-platform compute then, architectural decision matrix for asynchronous workloads then, event-driven offloading with Salesforce and AWS EventBridge then, buffer and execute, SQS and AWS Lambda processing pipelines then, enterprise security, JWT Bearer Flow and mutual TLS writebacks. Stay for the last one, it's the piece most tutorials miss. Let me explain this simply. Welcome back, future architects. Today we are solving one of the most critical CTA board exam scenarios. What do you do when native Salesforce governor limits block your complex compute workloads?
Can't we just chain queuable Apex jobs or reduce our batch Apex scope size to avoid CPU timeouts?
Imagine trying to run a high-speed Formula 1 engine inside a strictly regulated city street with a rigid 20-second speed limit. That is exactly what happens when developers force complex mathematical modeling, PDF rendering, or massive payload transformations directly into Apex batch jobs. While Salesforce handles transactional CRM business logic brilliantly, its CPU time and heap limits will crush heavy compute workflows under scale. As a certified technical architect, your primary duty is recognizing when to stop fighting platform limits and start offloading processing off-platform to specialized compute layers like AWS Lambda. Choosing where to execute your business logic requires a disciplined decision matrix rather than developer preference. If your transformation runs under 5 seconds, operates on small datasets, and directly manipulates core Salesforce records, native queuable Apex or batch Apex remains your cleanest choice. However, once you encounter long-running CPU calculations, complex image processing, or external API aggregations exceeding governor boundaries, off-platform compute becomes non-negotiable. The trade-off you accept is network latency and orchestration overhead in exchange for infinite scalability and predictable execution costs. The cleanest architectural pattern for offloading heavy compute is asynchronous event-driven publish-subscribe using Salesforce Platform Events and Amazon EventBridge. When a trigger event occurs in Salesforce, we publish a lightweight event containing minimal payload identifiers rather than massive record blobs. The EventBridge relay ingests this event with sub-millisecond latency and routes it directly to target downstream AWS services like Lambda or ECS. This completely decouples Salesforce from the compute processing lifecycle, freeing up your app servers and eliminating transaction timeout risks entirely. Once the event lands in AWS, we route it into an Amazon Simple Queue service queue before triggering our AWS Lambda function. SQS acts as a crucial buffer, smoothing out massive traffic spikes from Salesforce and preventing downstream target APs from getting overwhelmed. The Lambda function executes the heavy compute logic inside a stateless isolated container with up to 15 minutes of CPU execution time. Once the calculation completes, Lambda prepares a micropayload containing only the critical status update and final calculation metrics needed back in Salesforce. Writing results back to Salesforce safely requires robust enterprise authentication and authorization protocols rather than hard-coded credentials. We establish a secure connection using OAuth 2.0 JWT Bearer Flow combined with mutual TLS to guarantee both identity and payload encryption. The Lambda execution role retrieves a short-lived access token using a preconfigured Salesforce connected app equipped with strict IP restrictions and digital certificates. This ensures that even high-frequency writebacks adhere strictly to field-level security and tenant isolation guidelines without exposing long-lived passwords. In enterprise integrations, things will inevitably fail, whether due to transient network drops, target system maintenance, or record locking inside Salesforce. If an outbound callback fails, our architecture must automatically capture the failed message in an SQS dead letter queue rather than silently dropping data. We implement exponential backoff retry algorithms with circuit breakers to prevent flooding a locked record with retries. This pattern guarantees eventual consistency and alerts support engineers via CloudWatch alarms before system administrators even notice a discrepancy. The most dangerous anti-pattern I see in enterprise reviews is developers performing synchronous HTTP callouts directly from Apex triggers using continuation or synchronous Apex. When external services slow down, your Salesforce user interface freezes, trigger execution times explode, and active thread pools exhaust, causing systemic org-wide outages. Another common mistake is passing massive base 64 blob files directly through platform events, which exhausts payload limits instantly. Always pass lightweight record ID references across the event bus and pull payload details on demand. To bring this complete CTA blueprint together, start by identifying high compute bottlenecks in your current async Apex jobs. Leverage platform events to emit state change events into EventBridge, buffer messages with SQS, and process heavy workloads inside Lambda. Complete the round-trip state sync using secure OAuth JWT Writebacks with robust DLQ error handling. By mastering this off-platform compute pattern, you transform your Salesforce org from an overloaded batch processor into an agile, highly resilient enterprise hub capable of infinite scale. Alright, let's wrap up. Here are the key things to remember. Offload complex compute exceeding 5-second CPU limits to AWS Lambda using platform events. Use Amazon SQS as a buffer between Salesforce and AWS to handle burst traffic spikes seamlessly. Secure writebacks back to Salesforce using OAuth 2.0 JWT Bearer Flow combined with mTLS. Implement dead letter queues and exponential backoff to prevent row locking and data loss. If this helped, hit like, it really helps the channel. Next up, Salesforce off-platform caching masterclass, Redis integration blueprint pipe EP 2 second. See you tomorrow.